Hey guys, welcome back. Today we're going to learn a couple more derivatives, and here's what you need to keep in mind. These are the basic rules of calculus, the computation of calculus that we're going to use all year, okay? So please memorize them as you learn them, and make sure you're not looking at your notes every day to figure it out. Actually spend the time memorizing them so that your work is easier and easier as the year progresses. It would be like not knowing -3 + 5 and thinking you could do algebra 1, okay? These are the basic rules of the computation of calculus. So before we get started, this is really not a new rule. You just may not have known how to approach this. This is actually a power rule in disguise. So I want you to think about that for a minute. How could you do a power rule with this? Well, the key is to rewrite it before you get started. So as you know, the square root of x is the same as x to the 1/2 power. So this is x to the 1/2 power. But that still doesn't help me do a power rule. The key with this is to split it up. I call this an STD. I don't know what you're thinking, but it stands for single term denominator. If you have one term in the denominator, then you want to split it up, and you're going to write this over this over this, and this over this. And then simplify, and then don't forget to actually find the derivative. So let me clean it up and show you what I'm talking about. Okay, so first, split up each term. And remember that the square root of x is the same as x to the 1/2 power. And just put each term over the square root of x. Then simplify it further by subtracting your exponents. This is the same as if I had x to the 5th over x cubed. We know that that's the same as x squared, because it's x times x times x times x times x, 5 on the top, 3 on the bottom, and 3 of them cancel, leaving still 2 on top. So that's the rule we're using. Basically just subtract. So back to the problem here, 3 minus 1/2 would give me x to the 3 minus 1/2 would be 2.5 or 5/2. 2 minus 1/2 would be 1.5 or 3/2. And 1 minus 1/2 would be 1/2. Now, just don't forget, focus on your notation. We still haven't done a derivative. We didn't do any calculus. So now I'm going to actually do the derivative using the power rule. So multiply and subtract 1. You get 5/2 x to the, when you subtract 1, think of it as 2 over 2. This would be 3/2 times 2, which is just 3. X to the subtract 1 in the form of 2 over 2. And last, 1/2 times 4. Half of 4 is 2. X to the subtract 1, and you get -1/2. And then again, don't forget, if you get a negative exponent, just move that guy to the denominator. So these first two terms are going to stay the same, but the last term, the x to the 1/2, will move to the bottom. And that's everything. But be warned, remember, they could put it back into radical form. So the x to the 1/2 power, those could also be rewritten as square roots. And even the 3/2 power, that could also be rewritten as a radical. So while this answer is perfectly correct, if it was a multiple choice answer, then there's a possibility it could be written one more way. So the final option is to rewrite it in radical form, and that would be this guy. And again, it's fine if you left it like we did over here. Just know that if this were a multiple choice question on the AP exam, which is honestly likely, then there's a good chance they would write it back into radical form. Okay, so let's move on to today's lesson. My goal right now is to figure out what is the derivative of the sine of x. Well, to do that, I'm going to remind you that derivative means slope of the curve. So to find the derivative of sine x, I'm going to try to figure out what is the slope of the curve at a bunch of different spots. Okay, so it's not really a proof of the derivative. It's just kind of a, an informal approach. Well, for starters, let's graph sine x using our unit circle. At 0, remember this is cosine and sine. So at 0, we start at 0. At pi over 2, the sine is 1. At pi, the sine is 0. At 3 pi over 2, we're down to negative 1. And then back to 0 or 2 pi, we're back to 0. Wish me luck connecting these. And that's kind of sort of our sine graph, or at least a part of it. Okay, now what we're going to try to do is figure out the derivative of that. Okay, so our goal right now, we're trying to figure out what is the derivative of the sine of x. So if f of x is the sine of x, I'm trying to figure out what is the derivative of that by looking at the slope of the sine graph. Well, let's start with the easy ones. Where is the slope 0? Well, the slope would be 0 here and here. So let's graph that. A height of 0 would be this guy and this guy. Okay. Well, what about right here? What do you think that slope is? I mean, I know we're just kind of guessing, but is it reasonable to guess that it's definitely negative? Is it possible that if we did the slope of the tangent there, it might be negative 1? I mean, visualize down 1 over 1. Okay, so let's say that's negative 1. Work with me here. Okay, well, if that's negative 1, we know the graph is always symmetric for the sine graph, then does it seem reasonable then if that's negative 1, then maybe here we have a slope of perhaps positive 1, and same thing here. So positive 1. Okay, so if I were to graph all of those points, which is just the slope of the sine graph, try to focus on just the blue stuff, I would get this graph. Now let me erase all the black and go back to just the blue stuff. And remember what that was the slope of the black graph. Okay, so I'm going to clean this up and start over with a prettier picture. After several attempts, that's the best I can do. It's not the cleanest thing, but that's the best I got. All right, so the blue curve you're looking at right now is a graph of the slope of the original curve. So the original curve was the sine graph. Now your job is to tell me, what do you think this new blue curve is a graph of? Hopefully you can see that that is the cosine graph. Okay, so this is a cosine graph, and this was the slope of the first curve, which tells you, dun, 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 the derivative of sine is cosine. That's what you were supposed to get out of all of that. So if you didn't understand my explanation of it, it's okay. In the end, what you need to know is the derivative of sine is cosine. That's what you were supposed to get out of that. So put that in your notes. That's another rule you're going to have to memorize. Derivative of sine is cosine. So now I'm going to try to do the same thing again to figure out the derivative of cosine. And again, if you don't quite follow this, it's okay. In the end, you could just memorize, but I think it helps to visualize it. Okay, now I'm going to try to figure out the derivative of cosine. By the way, when you do the derivative of a derivative, then you say it's the second derivative. But in all honesty, I'm just going to be doing what is the derivative of cosine. So I'm going to pretend this is a new graph. This is my cosine graph. Okay, so repeating that same process, this is now the cosine graph. And I'm now trying to kind of figure out, guessing a little bit, what the derivative of cosine is. Okay? So remember, derivative is slope. So let's look at the slope of this curve. This would be a slope of 0. We know the graph continues over here, so this is also a slope of 0. And this is a slope of 0. Okay? In between, this looks like a slope of -1. And this would be a slope of +1. Now focusing on just the red points. I missed one of them. Wish me luck. Okay, now try to focus on just the red graph, and the red graph only. Okay, and what is that a graph of? Is it the sine graph? No, not quite, because it goes negative before it goes positive. Hopefully you can see that this is the graph of negative sine. So what does this tell us? The derivative of cosine is negative sine. So let's put those rules together in your notes and memorize them. So 2 new rules for you to memorize. The derivative of sine is cosine, and the derivative of cosine is negative sine. Maybe a little bit new notation for you here. Oops, sorry. Okay, so you could also write the derivative. I keep messing up. Some other notation you could use is the derivative of sine is cosine. Okay, but make sure you don't write cosine all by itself without something behind it. It's cosine of something. Okay, and the derivative of cosine is negative sine. Okay, and you do have to memorize that. A little trick: when I'm writing that sine is my answer, change the sign. When sine is your answer, change the sign. Okay, so for example, if I gave you the problem, f of x is equal to, say, 3 cosine x, the derivative would be negative 3 sine x. Okay, when you write sine, change the sign. All right, now there's one more rule for today, and that's e to the x, and I'm going to use my graphing calculator to help out with that one. Okay, your calculator can actually graph the derivative of something for you. So what I've put in it right now, and it's not hugely important that you learn this right now, but in y1, this is the graph of e to the x. In y2, the bold type, that's going to be the graph of its derivative. N derived means the derivative of y1, okay? So don't pay attention to the rest of the notation. We'll learn that another day. But we're graphing the derivative of e to the x. So we're going to have 2 graphs. The first graph is e to the x. The second graph is the derivative of e to the x. So here's the graph of e to the x. My y equals, I just typed in the e to the x part. Okay, so that's just the graph of e to the x right now. Exponential growth, you know and love it. Now I'm going to graph the derivative of it. And remember, the derivative is the slope. So kind of predict a little bit. The slope right here is practically 0, really close to it. The slope right here, I don't know, maybe 1. And then the slope right here is really steep. Okay, so what I'm going to graph in a minute is the slope of this graph. Okay, so I'm going to go back to my calculator and graph the derivative of it using my calculator. Okay, you haven't really learned this yet, but using the calculator to graph this derivative, I use a function called nderive. So it's math, I'm a little rusty, it's math 8, nderive, that's the derivative. Now, depending on the version of the calculator that you have, this could look different for different people, but I'm going to do the derivative with respect to x. That's always going to be an x right there. And then this, I could either say I want the derivative of e to the x, or I can tell it I want the derivative of what I had in y1. So to do that, we do that a lot, but I hit vars for variables, y vars, hit enter, and there's y1. So that's going to do the derivative of whatever's in y1. And now I want it calculated at not one spot, but all values of x. You don't really need to know that right now. We'll worry about that another time. But this is going to graph for me right now. It's going to graph the derivative of what we already have in there. And it's going to do it in red. So here we go. Your goal right now is to figure out what is the derivative of e to the x, okay? And we're going to do that by looking at the graph of the derivative. Dun, 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 dun. What does that mean? Okay, what are you supposed to get out of all of that? I literally graphed in y2 the derivative of y1. And the graphs are the same. So what are you supposed to get out of that? The derivative of e to the x is e to the x. So the whole point of that was one more rule. The derivative of e to the x is e to the x. Okay, so now memorize you have 3 rules today. Okay, the derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of e to the x is e to the x. And let's put it all together. Let's see if we can figure out the derivative of this problem. We have only 3 rules that we learned today. Derivative of sine is cosine, derivative of cosine is negative sine, and derivative of e to the x is e to the x. Just don't confuse e to the x with your normal power rule. So the first example, the derivative of this would be, the first term is just a regular power rule. This is just 6x. This derivative of e to the x is e to the x. The coefficient, you just bring it down. So this is 2e to the x. And for the cosine problem, the derivative of cosine is negative sine. So remember, when you write sine, change the sign, and this will be positive 5 sine x. That's it. Easy. Hope you're hanging in there. So the lesson is pretty much done, but if you'd like to just test your overall understanding of everything right now, then do these 3 problems. But I haven't taught you one thing that I see is in here, so let me change this real quick. I haven't taught you this last term, so ignore that last guy right there. And pretend it's not there. Now do the derivative of those 3 problems. Hit pause and work those out. Let's see how you do. So, how'd you do? On the first one, when you write cosine, don't change the sign. On the second one, when you write sine, change the sign. On the third one, you had a mix of everything. The e to the x is e to the x. That's easy. This guy's a power rule. This is a power rule. You had to rewrite it as x to the 1/2 power. Then when you do the derivative, you get x to the negative 1/2 power. Move that negative exponent to the denominator. And then you might also change it back into radical form, but you didn't have to. Just keep thinking that it's possible. Hope you're doing well. That's everything. Good luck with your assignment today. It looks like a lot, but it really isn't. Good luck.